Have you ever felt like something is pulling you in a certain direction? Well, it turns out our entire galaxy, the Milky Way, is feeling that same pull. For decades, astronomers have noticed something strange. Our galaxy, along with hundreds of thousands of other galaxies in our cosmic neighborhood, is hurtling through space at an incredible 2 million kilometers per hour. But what is even weirder is that we were not just expanding away from the Big Bang. We're also being yanked sideways towards a specific, unseen point in the cosmos. This cosmic mystery is called the Great Attractor. It's a gravitational anomaly, a massive concentration of something that's dragging us and a huge chunk of the universe towards it. So what is this thing? Is it a giant black hole, a cluster of dark matter, or something we can't even imagine yet? Let's dive in and explore one of the biggest puzzles in modern cosmology. To understand the Great Attractor, we first need to talk about how we even noticed it. It all started in the 1970s. Astronomers were meticulously mapping the universe, measuring the speeds and directions of distant galaxies. They were using the cosmic microwave background radiation, or CMB, as a reference point. The CMB is the faint afterglow of the Big Bang, a sort of universal backdrop that should look the same in all directions. But it wasn't the same. When they looked at the CMB, they found what's called a dipole anisotropy. That's a fancy way of saying one side of the sky appeared slightly warmer, or blue-shifted, and the opposite side appeared slightly cooler, or red-shifted. This told them that our entire local group of galaxies is moving relative to the rest of the universe. The direction of that movement pointed towards the constellations of Hydra and Centaurus. Something over there was pulling us, and pulling hard. The initial calculations were mind-boggling. The object responsible would need the mass of tens of thousands of galaxies like our own Milky Way to exert such a powerful gravitational force over such a vast distance. The problem was, when astronomers looked in that direction with their telescopes, they couldn't see anything nearly massive enough. It was a cosmic ghost. So why can't we just point our best telescopes at it and see what it is? Well, there's a major galactic roadblock in the way. The Great Attractor lies behind the plane of our own Milky Way galaxy. This region of the sky is called the zone of avoidance. It's not avoiding us. We're just avoiding looking there because it's so cluttered. It's filled with a dense concentration of stars, gas, and cosmic dust from our own galaxy. Imagine trying to see a distant mountain through a thick, dense fog. That's what it's like for optical telescopes trying to peer through the zone of avoidance. The dust and gas block and scatter visible light, making it almost impossible to see the galaxies that lie beyond. For a long time, this cosmic blind spot kept the Great Attractor's true nature a complete secret. It was a giant, invisible force lurking just behind our galactic curtain. But astronomers are clever. If you can't see through something with visible light, you try other types of light. In the 1980s and 90s, scientists started using radio telescopes and X-ray telescopes to pierce through the galactic fog. These longer wavelengths of light aren't blocked by dust as easily as visible light is. It was like getting a pair of special goggles that could see through the haze. And what they found was astonishing. Hidden behind the zone of avoidance wasn't just empty space. They discovered a massive supercluster of galaxies, which they named the Norma Cluster. A supercluster is a huge collection of galaxy clusters, one of the largest known structures in the universe. This was a major piece of the puzzle. The Norma Cluster is incredibly massive and sits right at the heart of where we thought the Great Attractor should be. For a while, many thought, case closed, the Norma Cluster is the Great Attractor. It certainly accounts for a significant portion of the gravitational pull we're experiencing. But as our measurements got more precise, a new problem emerged. The mass of the Norma Cluster, as immense as it is, still wasn't enough. It could only account for a fraction of the total gravitational force needed to explain our galaxy's high-speed journey. The mystery wasn't solved, it just got deeper. The Great Attractor was even bigger and more complex than we had imagined. If the Norma Cluster wasn't the whole story, then what else was out there? The search continued, pushing the boundaries of our technology. Astronomers conducted even more extensive surveys, using infrared and radio waves to map the distribution of galaxies over an even larger area of the sky. What they uncovered was something on a scale almost too vast to comprehend. It turns out the Great Attractor itself is just one part of an even more colossal structure. In 2014, a team of scientists mapped the motions of over 8,000 galaxies to define the boundaries of our home supercluster. They named it Laniakea, a Hawaiian word meaning immeasurable heaven. Picture Laniakea as a giant cosmic basin. It contains our Milky Way, the Virgo supercluster, the Great Attractor region, and about 100,000 other galaxies, all flowing towards a common center of gravity, like water flowing down a drain. The Great Attractor isn't a single object pulling us. It's the gravitational center of this immense supercluster we are a part of. The pull isn't coming from one thing, but from the combined gravity of everything within this massive structure. But the plot thickens even more. Even Laniakea, as gigantic as it is, isn't the final stop. When we look at the cosmic flow of galaxies on an even grander scale, we see that Laniakea itself is moving. The entire supercluster, our cosmic home, is being pulled towards something even bigger. This more distant and even more massive concentration of galaxies is called the Shapley supercluster. The Shapley supercluster is the largest concentration of galaxies in our local universe, a true cosmic heavyweight. It's located about 650 million light-years away, much farther than the Great Attractor region. It seems the gravitational story of our universe is like a set of Russian dolls. The Milky Way is being pulled by the local group, which is pulled by the Virgo cluster, which is part of the flow towards the Great Attractor region. And this entire Laniakea supercluster is being pulled by the colossal Shapley supercluster. So, what does this all mean for us, here on our tiny blue planet? Are we in any danger of being sucked into this cosmic vortex? The short answer is no, so you can relax. While the speeds are incredible, the distances are even more mind-bogglingly vast. We're talking about forces playing out over hundreds of millions of light years. But there's another, even more powerful force at play in the universe. Dark energy? Dark energy is the mysterious force that is causing the expansion of the universe to accelerate. It's essentially pushing everything apart, acting as a cosmic anti-gravity. In the grand cosmic tug-of-war, dark energy is winning. While the Great Attractor and the Shapley supercluster pull us in, the accelerating expansion of space is pushing everything away even faster. So, we will likely never reach our great cosmic attractor. Instead, our local group of galaxies will continue on its path, but the vast distances between superclusters will grow ever larger. In the far, far future, other superclusters like Shapley will be expanding away from us so fast that their light will no longer be able to reach us. They will disappear over our cosmic horizon, leaving our Laniakea supercluster as an isolated island in an endless, empty void. The story of the Great Attractor is a perfect example of how science works. It started with a small, puzzling observation, a slight temperature difference in the cosmic microwave background. This anomaly led to a decades-long investigation that peeled back layer after layer of the universe, revealing structures grander than we ever thought possible. From the Norma cluster to the Laniakea supercluster, and finally to the Shapley supercluster, each discovery solved one mystery while revealing an even bigger one. It shows us that our galaxy isn't just an isolated island of stars, but part of an intricate, dynamic cosmic web connected by the invisible threads of gravity. And even though we've learned so much, the universe still holds its secrets. The exact distribution of mass, especially the role of dark matter in these structures, is still an active area of research. What other cosmic titans are lurking out there, shaping the fate of galaxies across the cosmos? The universe is constantly challenging our understanding and inviting us to look deeper. The journey to understand our place in the cosmos is far from over. Thanks so much for watching. If you enjoyed this journey to the Great Attractor, don't forget to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments what cosmic puzzle you'd like to explore next. Until then, keep looking up.